Hello everyone, thank you so much for another special time together. So here we have a question, say that calculate the volume of residual gases which will be produced if 24 cm3 of ammonia gas combines with 34 cm3 of oxygen at temperature above 100 degrees Celsius. Now, where we have a chemical equation of the reaction, in this chemical equation we have the ratio of 4, 3, 6 and 2. So this ratio tells us about one of the important things that the ratio represents here, according to Gay Lussac's law, is that it tells us the volume of their combination. The volume of their combination is what is showing us, according to Gay Lussac. This is the simple ratio of one another, and the volume they they do so what in a simple ratio. The volume combine in a simple ratio with one another, and the what to that of the product. So this is the ratio of the product that you're going to have here. So in this case, we want to find out the residual gas. At the end of this reaction, we find out that some of the reaction, for example, if anyone that is in excess is not likely to go into reaction, they will always combine based on the ratio of their combination. So in this case, we have 24 cm3 of ammonia gas combining with 24 cm3 of oxygen. So let's go ahead and see what we're going to do here. So in this case, looking at oxygen and ammonia, we have 24 here. Now it means that 4 cm3 of ammonia, 4 cm3 of ammonia will combine with what? 3 cm3 of oxygen. So 24 cm3 of ammonia will then combine with 3/4 times 24/1. So here we have, this can go up, go here, we have 2, here 12, here again we have 1, here we have 6. 3 times 6 we have 18 cm3. That means what we react with 24 cm3 ammonia is 18 cm3 out of what we have here. We have 34. That means oxygen is reacting in excess. So that means the extra oxygen that is there that did not react, we have minus 18 will give us, this will give us this other will give us 6, the other one will give us what? 16 cm3. That is 16 cm3 of oxygen did not react. So 16 cm3 of oxygen did not react. That means this 16 cm3 of oxygen is part of our residual gas we are looking for. That means 16 cm3 of what? Oxygen is part of our residual gas we are looking for. Now we'll go ahead to find out, so that we are calculating the volume of residual gas. Now the next one we're going to find out is what happened between ammonia and the steam. This, from the equation, we notice that this one is a gas, and judging from the temperature, it means that it remains a gas to the end of the chemical equation, because water remains a gas at temperature between 100 Celsius or above. So let's go down and see what we will get when ammonia combined with oxygen. The volume of water vapor that will be produced, or the water vapor, yes, that will be produced. Then from here we notice that 4 cm3 of what? Ammonia will give us 6 cm cubed of what? water and the gas anyway. Alright, so in this 24 cm cube of what ammonia gas will give us so what we have here is that 2 can go here, 2 here, we have 12, 2 here again, 2 here, we have 6. 6 times 6 we have 36 cm cube of water vapor. 36 cm cube of water vapor. That is what is produced in the case of this. In the case of this one now, and also this water vapor, the volume is also part of our gas. We are looking for the residual gas because this is the gas that will remain after the chemical reaction. So of gas, that's G gas. Okay, the next one we're expecting to get is nitrogen. In the case of nitrogen now, we have also 2 cm cube. So in this 2 cm cube means that nitrogen ammonia, 4 cm cube ammonia will combine with oxygen to give us 2 cm cube of this my cm cube, this one. So 2 cm cube of nitrogen. So in this case we come here again, say that of what ammonia will give us 2 cm cube of nitrogen. So 24 of what ammonia will then give us 2/4 times 24/1. Here will give us 1. Here will give us what? Here will give us another 2. 2 here we have 12. That means 12 cm cube of what? Nitrogen. That's what we're going to produce. We're going to get from there. So at the end of everything, the volume of residual gas will then be. We're going to add up all the gases. This other one is 12 of nitrogen. So when we add up everything, the volume of all oxygen that did not react, we add it up. Volume of oxygen which did not react, we have it to be what? 16, and then volume of water vapor produced, we have 36 cm cube, and then volume of nitrogen, perhaps nitrogen will have 12 cm cube. So when we add it up, we have 6 here. This is 6 plus 6, we have 12, 13, 14, we have 4. Here we have 5. We add this one, we have the one we have. That means the volume of the residual gas we have. The volume of residual gas we have there should be what? 64 cm cube. Alright, thank you so much for being a part of our program today. We hope that you will subscribe to our channel. Thank you.